Thank you, Daniel. Our panel discussion will be held in English, therefore I switch into English language here right away. And I'm very happy to welcome you. Good morning, everyone, and welcome you to the opening panel of today's Construction Equipment Forum. My name is Matthias Thomendal. As Daniel said, I'm a management professor at Berlin School of Economics and Law, and I'm your moderator for today. Right in the beginning, we are here to explore the important and highly topical issue of the future drive mix, where hydrogen e-fuels and electric drives will be utilized. As the construction sector faces increasing pressure to reduce emissions and improve sustainability, the choices we make in drive technologies will shape not only the future of our projects, but also the broader environmental impact of our industry. So today we'll be discussing how these emerging technologies, again, hydrogen, e-fuels, and electric drives, are evolving, their potential applications, and the challenges and opportunities they present. We'll dive into the complexities of integrating these different drive technologies into our equipment fleets and explore where each is most likely to thrive. And for this, I'm very happy to have a fantastic group of experts here this morning that bring valuable perspectives from across the sector. I look forward to an engaging and insightful conversation also with you. As Daniel has explained, please be very active, ask questions, vote for questions, and therefore you can also have an active part and determine what we will focus on in the following 35 minutes. So, but now let's get started, and I'd like to introduce our panelists. Maybe we go one after the other, as I'm standing here alone at the moment. So today, please welcome basically the host, Frank Zander. He's the Managing Director for Sales Europe, Global Major Accounts here at J.C. Bamford Excavators Germany. Please give a big applause to Frank. One further, please, Frank. Thank you. Then we have Tobias Reh. He's Team Lead E-Mobility Off-Road at Schaeffler. Welcome, Tobias. I'd like to welcome Holger Hoppe-Pietsch, the Business Development Director at Moog Construction. Welcome, Hoppe. And last but not least, Adrian Huber, Research Assistant at the Technical University Munich. Fantastic panel. Here we go. Take a seat. So we know what the topic is. We will basically talk about three different drives, and maybe in the beginning I would like to ask the scientist for a kind of objective and theoretical introduction. Adrian, could you please briefly explain what these three technologies are, what they entail, what the main advantages, characteristics, let's say from a theoretical point of view are?
Yes, thank you very much, and thank you also for the opportunity to be able to speak here at the Construction Equipment Forum. Yes, to answer your question, obviously the main drivetrain concept talked about right now is electrification. And looking at electrification, you really have different options, right? You can go with battery electric, you can go with electrification by wire as well. The main advantage of electrification, zero emissions locally, and a very high efficiency in terms of the efficiency of the machine is just higher than comparable engines or drivetrain concepts. However, regarding electrification, you obviously need to take into account the infrastructure that encompasses, on the one hand, how the power is produced. So, for example, in Germany, we have a quite significant carbon emission associated with power production, and obviously you also need to take into account the local infrastructure on the construction side. So really what you have then are some inhibitions in terms of where you can electrify and where you can't.
With electric drives, we know we have an electric motor, basically. How about e-fuels? What are exactly e-fuels?
So e-fuels are very interesting from my point of view, because obviously when you're looking at e-fuels, you're looking at a loss in efficiency, because you obviously need to generate the e-fuel beforehand, and then you can use it in the machine. However, the main advantage of e-fuels is that you can really use it for legacy machines. We tend to have machines which have very long lifetime in the market. So basically, if you're buying a machine now, this machine may very well run until 2040 or even longer. And e-fuels are really the only possibility, or the easiest possibility, to make that machine carbon neutral in the future. Last but not least, hydrogen, also very interesting, but from my point of view, it's still far off in the future. I can elaborate also on hydrogen if you want me to. With hydrogen, you have still a debate between fuel cells and combustion engines. This debate is, from my point of view, still open. However, I see a few advantages for combustion engines in construction appliances.
Let's discuss. Okay, so we have these three drives. Heard a bit about, let's say, theoretic or technical advantages. Now let's take some time, I would say, to go into practice. Talk about practical applications, experiences, use cases, and what your view is. I suggest maybe to go one after the other and start with electric. We saw this is our key topic, maybe even for the whole day. Frank, JCB and electric. What is your view? What are first or major experiences already? Maybe you can kick off that discussion.
Yeah, first of all, thank you very much for this info, Tobias. It is, from our view, we have started quite early also with electrification of machines, which is now almost 8 years in the field. We have already a fleet running. There are definitely advantages, and when you drive first time, I'm more the practical guy, when you drive first time an electrical car or also a construction machine, you like it, you love it, because it is quiet, it is, you feel the performance of a machine. It's very similar to an engine, but it's no noise. So there are a lot of and pollution as well. So there are a lot of advantages, but we have also seen limitations, especially when it comes to higher energy, and therefore we have seen that we see limits at around 75 kilowatt,
Okay.
roughly. What stops us to make it economical, logical, because at the end of the day we need to see also costs, and this is what we are facing at the moment. The costs for batteries, but also at the moment, I'm talking about the current situation, we see a decline also in the demand of electric machines, especially in Germany, because the consumer is not willing to pay 1.7% more than a diesel engine, as an example. So, and this is the practical point of view. Therefore, we have taken the decision to looking for other alternatives, and one alternative could be potentially hydrogen, which gives us then more opportunities also.
Okay. Let's talk about hydrogen then afterwards. Tobias, talking about electric. What is your view? What are your practical experiences?
From a market point of view, it's actually really depending on the application. So also then great that JCB is showcasing here different kind of vehicles, and you also then see some are more stationary, some are more mobile, and I think that is also a bullet point for deciding in which category you are going actually. Also then the size, obviously, as is the topic. So what we see more is obviously the smaller ones with power 20, 30 kilowatt, something like that. That is definitely currently going in the full electric direction. Above that, and that's what Frank said as well, 75 kilowatt. I think it's not black and white, it's a gray zone also, is then more the tendency in different directions.
Okay, good. And Hoppy, may I call you with your your view on kind of the status and practical experience maybe of electric drives?
First, quick introduction. Moog, maybe not as known as JCB or the University of Munich. So just quickly in Moog, what we do is we do motion control. That means we transform energy into motion, hydraulic, electric, hydroelectric. We do this mainly for planes. 3 out of 4 planes between the pilot and the rudder is driven by Moog Technologies. We do this for rockets, we do this in defense, we do this for medical devices. So we know a lot about motion control. And what we like about motion control, it has to be efficient, energy efficient. So that means the more efficient the motion control on a machine, the less energy you need to put in the back. Fuel, hydrogen, batteries, whatever it is. And the other thing that is important for us is, it should be safe and it should be programmable in the future. So we'd like to see several of these technologies converge into something that is the utmost efficiency for a piece of equipment. So from that point of view, our feeling is electricity basically is the leading path here. You want to find an electric system, not only zero emission, but you find it easier to program, and you're going to find it easier to make functionally safe, in our opinion. So practical applications now, we find a number of areas. We work with some OEMs that now have fully electric equipment. That means no more hydraulics, no more diesel engine, and obviously these things in terms of their ability to bring in outside information, like the likes of Trimble or like our geospatial information for autonomy. All of those are a lot easier handled in an onboard computer that runs an electric system. And I think we then also need to talk a little bit about, getting a different energy-driven piece of equipment is a little bit like getting a horse. It's not just about getting a horse, it's about how do you maintain the horse, how do you keep the horse safe, how you keep the horse healthy. So there is an entire supply chain also that needs to be taken into consideration, which I think you alluded to when you spoke about infrastructure.
We'll talk about, let's say, processes and the whole system. Do you see the same thresholds with regard to size as the two former panelists have mentioned for the suitability of electric drives?
I think at some point, technically, you can drive larger batteries, and electrification in mining today is like a standard technology. I think what needs to be taken into account is more the economical factor. If you put a large battery on some of these pieces of equipment and they don't work, which most of the time, lots of them seem to actually spend a good chunk of the time waiting for other things to happen, then it's very expensive to electrify a piece of equipment with an integrated battery. So from that point of view, we feel that a swappable battery you can take out and do other things with seems to be a system solution that might be more adaptable as you move into larger pieces of equipment with lower utilization rates. But technically, you can electrify a mining truck these days that fills half its hole. So I don't see size. Size doesn't matter.
Size doesn't matter. Interesting. Maybe you would like to reply, because I mean, it's not one thing is, let's say, technical feasibility that the researchers could develop, but then you already talked about economic viability also. How about, let's say, practical application, especially also for the charging infrastructure, Frank?
Yeah, I really like the comparison with horses, because everybody who is carrying a horse at home knows that a horse is the most expensive animal which you can carry. So therefore, I think this is a very good comparison. And from my point of view, is if you just take at the moment, there are some good solutions on the market, also with the exchange of batteries, but it depends very much on the application. And what Tobias said also correctly, it depends really on the machine and where the machine is also utilized. If you are in a certain market somewhere in the jungle and you need electricity, there is nothing, so there is probably an alternative fuel system more interesting than a battery. So that depends pretty much on the situation, and it depends also on the infrastructure. I've seen already a question on the panel where the infrastructure should go, and if you look just to the network which we have currently around us, especially in this market here, then you see also limitations with the electrification. If everybody goes now on cars, electric cars, then there's definitely not enough energy source available simply. And that is also something what we need to look at.
Tobias, what's your view on the importance of charging infrastructure? How much does it determine? How much does it limit also the development of electric drives in, let's say, basically larger applications then?
It's again that thing which we already said about stationary versus mobile. So if not fitting really to construction here, but for example, farmer, agriculture, you have the energy production there, you can use it, and if you then go around your farm, you can with that then charge your batteries. The same might be if you're then on the construction site in the cities, then actually you are also somehow stationary, can then use maybe if it's a container or if it's a cable from a transformation station, whatever, that suits. But if then construction is most likely there for building infrastructure, then you have always the topic how to bring infrastructure to a place where no infrastructure is. So, and that's why also then this hybrid or not fully battery electric might make sense, because obviously we are talking a lot about the traction, but it's also about how can we, from a global perspective, reduce CO2 emissions, fuel consumption, with that also cost. We understood obviously for the end consumer costs is one of the key things, so that the customer is looking for how many tons can I move in an hour, and with that, how much does it cost? And the same question will then go to the producer of that machine, and also then to us as a supplier, as an example. And therefore, it's also relevant to look on the auxiliaries, and with that, to find a way how can I really reduce the footprint, the CO2 emissions, costs maybe, then increase productivity and things like that. And I think there's no black and white. It's really then application, as we said, then where it is, and then also from a global perspective, is it all about traction, or is it maybe reduction of hydraulics? So for example, bring in the electromechanical actuators as an example, or it also makes sense if you look at where do we have for an excavator, you have a traction drive, you have also then a swing drive. So does it make sense to decouple that, not only have one big aggregate, but really have separate ones, and with that increase efficiency? So
okay, so we are here right in the middle, let's say, discussing also hybrid solutions. I saw you nodding, Adria, where there are different types of engines in one machine. Maybe we take then also this first question, and I'd like to ask you maybe to elaborate a bit what your view is from the perspective of research or maybe even forecasting. How do you see the potential of diesel electro hybrids, and then especially also for bigger machines?
Yeah, thank you very much. Very good question, actually. And I want to make or pick up on the point you just made. Exactly, you really need to look at the applications of where it's taking place. I think this discussion is much more complex than people usually acknowledge. And that's because it's not as easy as just electrifying a given machine, and when you're carbon neutral, everything is fine. You really need to look, where does the application take place? What's the customer like? What's the infrastructure he has in place? What's the application spectrum he does with the machine? Because some customers buy one machine and they have one task, and the machine does the task for all its lifetime. Other machines are very complex in their task spectrum, so they do very different tasks. So yeah, the potential of these electro hybrids is actually, in my opinion, quite significant, because it allows for the flexibility. Because if you're a customer and you buy a machine, and you know when buying the machine, you really can carry out only a certain type of task with it, because it's just limited in its range, in its application duration, it needs infrastructure in place. You're just limiting yourself with the machine. So not only are you paying a premium for the electrified machine, you're also limiting your application range. And which customer, or there are very few customers who know what we are going to do in 5 years with the machine. So looking at really making the machine more efficient via these electro hybrids or via decoupling drivetrains. Very interesting concept. We've seen that in wheel loaders for a long time now, and although customers pay a premium for it, it is quite, in my opinion, has gained quite significant traction in the market. So, yeah, this issue of the title of the talk says it all, the drive mix of the future really makes things much more complex. Not only for companies building construction equipment, because we need to develop different drivetrain concepts, but also for people in the market using construction machinery. Because all of a sudden you have 5 different machines, and all of them employ different drivetrain concepts. So one is electrified, one uses hydrogen, the other 2 are running on combustion fuel. So very difficult, and therefore we really need to look into making the machine more efficient. And yeah, these electro hybrids may prove a very viable solution.
Yeah. I think it will be also one of the topics of one of our next panel discussions, how to bring all the energy sources and bring the energy mix together at one construction site. So you see big potential. For how long? For how long do you see diesel yeah, to
Yeah.
be alive and then be part of maybe these
That
hybrid
is a very,
solutions?
very good question, and what we need to consider is we need to consider this on a worldwide scale, right? So this will depend mainly on the market. We will see some markets where regulation will be very progressive, meaning that in Scandinavian markets, for example, there will be very progressive regulation towards full carbon neutral machinery, and where we will obviously see a quite quick adoption of electrified machines, for example. We will see other low regulated countries, and where I can't really tell you how long this is going to run for, maybe for decades to come.
Yeah, let's have views of the other panelists as well. Hoppy, how do you see the potential of diesel electro?
Well, first of all, we're going to run out of diesel. So we got to find an alternative. It also turns out that it's not good for the environment, so we should come up with a different alternative. I'm not a big fan of making things on machines a lot more complex because they run in the dirt, you know, they're out there moving stuff and they need to be repaired, they need to be maintained, they need to be troubleshot. And, you know, this is an environment that benefits from simplicity, not from complexity, and I think the diesel engine has done a marvelous job in doing this. I feel a lot of a machine would be simpler to run and maintain if it was electric, but believe it or not, I could see in the interim a future where you have a diesel-powered generator, one that creates electricity for maybe 4 or 5 machines on the job site that are fully electric, but rather than burning diesel in every machine, you burn it in one place that is stable, controlled, highly efficient. That is a diesel generator. It creates energy for these pieces of equipment, and eventually that generator I could see replaced by a hydrogen fuel cell.
Okay.
So for me, that would be more efficient. I mean, just think about how this works, right? I mean, we take stuff out of the ground in the other side of the world, we put it in a big tanker, bring it all the way over here in a chemical factory, then redistribute it, and then we basically combust it in a little iron case, which generates 60% heat and 40% energy. That's how we run the economy. And you know, if you came from outer space and looked at this, you'd say, well, who came up with that thing? And so I think there are like way better ways to power construction equipment. And again, it's not just about zero emission. I think a lot of it has to do with autonomy, programmability, integrated safety. And then from that point of view, the more complex you make a system on the machine, the more complicated it is to run in the longer run.
Let's hear the views of the two of you and your companies. What are your experiences? What is your view on the future of diesel electro hybrid? Who would like to start? Tobias.
Yeah. Actually, I think the question was, is there a potential or more potential? It's already there. So we had the example with mining. So there it's already best practice, because also then from a mechanical aspect and point of view, it's not possible otherwise. And obviously, also here the point is then to increase efficiency. So removing some of the hydraulics, you gain up to whatever 20% efficiency. So that's a big plus, and that's also what we see on the market. Some say it's an interim solution as well. So until the other technology is there from a pricing point of view, but also technology point of view. But it's definitely a point where you can say, okay, this is my next step. So what I would say, and what we see actually then also from Schaeffler side, is there are certain phases in the development of new technologies. So it's also a bit comparable to the automotive market, but some years later. So it's actually something like retrofit. So you have your existing vehicles, then you remove something like hydraulics, bring in electric motors, so substitute it with that. That might then be the diesel electric. Next step might then be the native electric, being it battery, being it fuel cell, being it something other. And then maybe, and that's now the point also Holger mentioned, with autonomous driving, optimize the human-machine interface and things like that, really make full controllable vehicles. And therefore, we also need then something like electric power, because then just with the diesel mechanical movement, it's not possible to really interact with software and so on. So yes, there is high potential, and maybe it's a question also how fast the other technologies move forward, and with that, how long you will take diesel electric, being it because of there's not diesel available anymore, or because other technology is more cost efficient and maybe also more efficient in
Yeah.
itself.
I noticed that in your retrofit phase, e-fuels did not play a role. Is that your view?
I didn't say that, so it's actually
You
so
just
it
didn't
was
mention
just
the
an
e-fuels.
example. Yeah,
Yeah.
I would say it's about productivity efficiency, and with that costs, because that matters. And if you can then sell also from an OEM side of point of view, you can sell a TCO decrease to the customer, then it's interesting for the customer. Otherwise, why should I buy this machine if it's double the price or third the price? But if you're saying, hey, maintenance is lower, there's no fuel consumption, energy has a certain price point, and with that, that's why I'm going more in the direction of.
Yeah. So you're skeptical
said,
if you.
No, that's
from a cost perspective. Frank.
We are also skeptical. So we see battery or the hybrid solution diesel as a bridging period. For bridging period, it's fine, but if we develop machines, so in the past 20 years, we have as an industry or as a manufacturer, we have tried to reduce the emissions, radical NOx and all oxides that are all reduced. But of course, we are creating still CO2. Yes, we are saving diesel, which automatically leads to the fact that we are also saving some CO2. But at the end of the day, it was said also by the governments that we want to be carbon neutral, and everything what we develop, we need to look at decades, not in 10 years time, so or 5 years. So therefore, we have looked to alternatives, and then we came automatically to the topic of hydrogen, because we think hydrogen as an element is first of all very interesting. It is very light. BMW did the experience also some years ago, but at that time the technology wasn't there. Now we have the technology available. We can save 30 kilowatt per hour in 1 kilo hydrogen, which is as an element the best medium you can get. And then we have decided to develop our combustion engine, where we see it is much faster developed, it is very easy and practical to handle, and the cost effectiveness is incredible, because we are talking here about 1.2, 1.15 compared to a diesel. And we can use it exactly the same. And therefore, we are more fanatic, I would say, to launch such a product as a combustion engine which is using hydrogen as a medium. Yes, of course, we have a few challenges. It's not all done, but we think also with the storage, which we have a lot of development work going at the moment, also in the storage system, that we have a mobile solution or a stationary solution available, and it is then very practical. It is comparable to a diesel engine if you want, and therefore we are moving away from the hybrid, which is anyway decided that we go out of diesel.
Very, very interesting. Opi, are you just as fanatic about hydrogen? I know you have some experience also from
I think
Wilhelmshaven,
hydrogen on a machine
area.
is actually, it's a beauty. I think where I look, I'm not saying I'm not convinced, I just don't know how to crack this one. There are two things about hydrogen where I like to be more comfortable. One is the whole, how do I get hydrogen to the machine? A lot of people feel very uncomfortable with the fact that it's, well, it can explode, right? So you need to make sure that whatever you come up with is extremely safe for the last 500 yards across the job site. And I've seen some very interesting solutions, but it's obviously a key area where today I feel contractors asking those questions. And the other one is, you know, an emission-friendly production of hydrogen. You know, there are some geographies where if you have an abundance of wind, hydrogen is a great way to take that energy and conserve it in hydrogen. There are other parts of the world where you don't have that, and then the production of hydrogen is a little bit more complicated if the goal is to be carbon-friendly. But on machine, I think it works. It's been proven. I think JCB is one of the leaders in this technology. It's the rest of the horse, I think, that requires consideration.
Yeah. Adrian, from a research point of view, we take that second question. What role do you see for hydrogen compared to e-fuels and electric drives in the future of distribution?
Yeah, I totally agree. The engine itself, so the technical part on the machine itself, very attractive. It's a beauty. Can't agree more. As I'm from a chair which also deals a lot with construction logistics, I can already say, and it's very difficult in terms of logistics and handling, because once again you need to get the hydrogen to the machine on site. You have different storage systems. You need to have a standard. You need to have a charging infrastructure, and it's not that easy. We had the argument beforehand about we produce oil in some faraway part of the world and we ship it across the country, across the world to our machine. The same thing basically will happen with hydrogen. We will produce the hydrogen, I don't know, in the Sahara Desert or wherever, and then we will have to transport it to the machine on site. And this will be the main challenge. So setting up the infrastructure will be a huge overhead from an economic point of view for the machines. Apart from that, if you can get the hydrogen onto the machine in an efficient manner, it's a very interesting technology.
Frank was just saying, so you are not as
No,
skeptical
I'm
as
not.
with
I
logistics.
think yes, we need definitely some. There are some lessons which we need to learn. But on the other hand, we are transporting gas in all variations from A to B. Hydrogen is nothing different. We just need the right containers, the right vehicles to distribute hydrogen. It's nothing else than diesel today, in my view, except of the fact that there is a high pressure on it. But high pressure, we are used in our industry, we are used to work with high pressure systems in the hydraulics or wherever. So hydrogen is not a big difference. And if there is a leak, it is not exploding or all this bullshit. It is just going up in the air, and so therefore it is even if there is a leak or something, of course you need not to put some flames in there. But
Okay,
but that should be solved, and we have also seen the concept already on a dispenser where you can inject fuel. And by the way, we have sold already 550, just our company, 570 buses by yesterday. With hydrogen. So hydrogen is getting more utilized, also in combination with a fuel cell, and we have already just in Germany 135 fuel stations existing. So it is also not new, and even in the bus industry, that is also becoming more interesting because it's simply efficient.
Fuel cell, your experience is there?
Our experience in fuel cell is it depends, and then coming back to the application. In our industry, we have a lot of dirt, and we are in rough terrains, and we are not in the clean environment like a bus or a car. And the difference is in construction industry that the fuel cell is very sensitive in terms of dirt and climate, also temperature and everything. So therefore, for us, we have tested some machines, but they were not reliable for our usage of our customer, and the customers would not be satisfied.
Interesting. I mean, Tobias, maybe more with regard to your role, the proponent of electric drives. Do you see hydrogen also as optimistically as Frank?
It's definitely also part on our strategy, actually. So
phases.
We are focusing very much on the fuel cell stacks,
Okay.
one for example, but also then coming from the engine components, also then the hydrogen combustion is a big topic at our side. So we are wide open, actually, what the customers want and are looking for. So it's talking about Schaeffler and talking about our strategy is really being technology open and go in the direction in which the customer wants to go.
Okay. Now let's talk maybe about the infrastructure a bit, which and that means also about the whole system, I would think, of energy usage and energy distribution to the construction sites and to the construction industry. So how will infrastructure development the paths of the different drives? What kind of developments do you currently see, Adrian? Let's put it like that, very generally.
So in the near to medium term, obviously electrifications or massive expansion of the grid will have to take place in order to power as many construction sites as possible with as much power as possible. That's basically the main challenge. So if you're looking at Germany, for example, you have many areas where it's not really possible or even feasible to just provide enough power for electrified machines. It's just very difficult for grid providers to provide that much power in a single point in time at any space. So basically this will have to take place in order to really enable electrification on a large scale. And this is, I think, the main concern for many practitioners, that we're not able to power the equipment in any remote or far-off areas. That's also next to, obviously, we talked about the price points of electrified equipment. That's the main concern from my point of view. And also you need to look at the cost, because it's actually very expensive to provide power in a remote place, and especially high peak powers. So yeah, next to regulatory factors and political factors, infrastructural factors will play the most important role in determining the drivetrain concept of the future, especially when talking about enabling electric drivetrains, but also for hydrogen. And from my point of view, it's still open. Also, the share of hydrogen, the share of electric drivetrain, and this will depend very much on these infrastructural factors.
Hoppy, a view on the, let's say, external environment with regard to your companies, but then still part of, let's say, construction value network infrastructure development. How important, how fast will things
sometimes go? You know, it feels that when you're in this, you're solving a societal problem, not an economic one, right? And so that means, you know, we have to decide if we want to crack it in this generation or the next one. And so obviously the infrastructure needs to be there if we want to get rid of diesel one way or another. You know, we need to find alternative ways. And I think as taxpayers, as parents, you know, we just have to bite this bullet at some stage. Personally, you know, I think the world has a pretty good track record in running electricity around. We all use it in our homes, so I'm a little bit biased. Where this electricity comes from, I'm extremely unbiased. I think, you know, whatever you want to pump into the cable, if it comes from hydrogen fuel cells, power stations that run nuclear or whatever it is, I think I'm fairly open. But it is clear that today you cannot put the entire burden on the OEM. It's impossible to kind of solve an entire infrastructure for a given country or region as a manufacturer. You cannot put it on contractors either. You know, I mean, in the end of the day, their expertise is to build roads and you know, whatever needed as physical infrastructure to live in. They cannot each become experts in how do I power my job site with multiple energies across multiple supply chains. And so that's just an area somewhere where I think more clarity is required, more investments are required. But you know what, I'm not running for any political position. I have to trust that the people I vote for kind of crack this one for us.
So you were very optimistic, Frank. Is infrastructure development also part of your optimistic scenarios?
I would take a political decision. I would say what we are doing at the moment is it's definitely not enough. We put not enough capacity in the network. We need electricity. Whatever we would like to achieve to be carbon neutral, if it is hydrogen or electric, doesn't matter. We need investment, heavy investment in infrastructure. And if you are looking to other countries around us, they are pretty much in a better shape than we are at the moment. That has also to do with a lot of political burdens, I think. And so therefore, from my view of view, it is very important to invest here
so
first.
A plea for a political, maybe even also regulatory side. One thing we have not, let's say, explicitly mentioned, but I think is also important, is what do the customers actually want, or how do they look at it with regard to drive mix? Adrian, you were nodding. How
yes,
do you see
so
it?
that's a point I alluded to earlier. If I'm a customer, it really depends on the application I want to do with the machine, right? Because I'm not buying the machine because I like excavators, I'm buying the machine because I want a certain process to be accomplished. And as a customer, looking at drivetrain concepts or the future of my drivetrains, I really need to look at the processes I want to accomplish. Maybe I want to apply for many construction sites which are in inner cities, for example, or which are in far-off areas. And this will influence the way I go about my drivetrain concept. So for example, if I'm doing a lot of work in inner cities, electrification might make sense. If I'm doing a lot of work at highways, electrified machines are not that feasible. So as a customer, I need to first look at my applications. Then I need to look at the machines I need to perform these applications, and then I can determine, okay, this is the drivetrain concept, this is most advantageous from an economical point of view, or maybe even if I'm an idealist, from an ecological point of view.
Okay, Tobias, from your point of view, do the customers follow that, let's say, rational decision-making order? So what do the customers feel?
Yeah, also, you mentioned it being in the city and so on. Another point is also then, now I'm missing the English word for it, but bauen im Bestand. So if you're really working in buildings and so on, you're also not allowed really to drive there with your diesel vehicle and so on. So it really depends, as we said, on the location.
But do the customers always have a kind of clear view, or are you kind of in a planning process together with customers and make common decisions?
Nowadays, it's really a combination, a partnership, I would also call it, so that obviously the customer has a certain idea and obviously a strategy where to go, but in the end, it's also about gives something like a guidance, also from expertise, from experience, what you have then done before, so that you can maybe also say, this might be the direction to go.
So you need to look in complete solutions, not only in machine type of solutions. Frank, also your view?
That is also my view. I think when I've met a customer just a week ago who run in Norway, and they tested just electrical excavator, 16-ton machine. They were absolutely fascinated with the machine. When you put such a customer on a machine, they are proud being there because it is so quiet. The environment totally different. But then it comes also to the cost, because if you have high subsidies on it, which is the subsidy is incredible, and then 650,000 euro for such an excavator, then is the question, makes that economically sense again? But as I said, I think from the fun point of view, the drivers, the customers are very happy to have such a machine.
Very good. So thank you very much to the four of you. And a big hand of applause, please, for our panelists that kicked off this day. I think we heard many aspects that are worth discussing further during this day, and during tomorrow there will be a lot of time for you also to approach the panelists and talk to them. So thank you very much to the two of you, to the four of you.
Thank you.